Hello, everyone. We will talk today about AI video generation technology. A turtle with a shell made of stained glass. A historical footage of California during the gold rush. That was never filmed. This is not a dream. This is not a big-budget VFX studio. This is the output of a machine that was given a single sentence. What you just saw represents one of the biggest leaps in artificial intelligence, generative video. While image generation felt like a revolution, video generation feels like a quantum leap. But how is this even possible? Today, we are pulling back the curtain on Sora, Runway, Pika, and the other models that are teaching AI the art of movement and time. First, let us talk about the leap from 2D to 4D. It is all about time. To understand video generation, you first have to understand what makes it so much harder than image generation. The key difference is time. An image is a 2D grid of pixels. A video is a 4D tensor, a stack of those 2D grids, where the third dimension is time, and the fourth is the RGB color channels. The challenge is not just making each frame look good, it is making them all temporally coherent. This means the AI has to understand physics. It has to know that if a person takes a step forward in frame 1, their foot must be in a different, logically consistent place in frame 2. It has to understand object permanence, camera motion, and cause and effect. This is an immense computational and conceptual challenge. Let us now explain the engine room, spacetime patches, and diffusion. So how do they do it? The current state-of-the-art models, like OpenAI's Sora, use a brilliant architectural concept called spacetime patches. Think of it like this. Instead of processing a video frame by frame, the model breaks it down into tiny 4D cubes. Each cube contains a small piece of the visual information and a small piece of the temporal sequence. This is the video equivalent of the tokens that language models like GPT use for text. These patches are then run through a diffusion model, similar to image generators, but supercharged for time. The model is trained on millions of videos to learn how to denoise spacetime. It starts with static, a cube of random noise, and iteratively refines it, not just to look like a thing, but to look like a thing moving correctly through time. So, what is the secret sauce? We mean physics engines and 3D understanding. But the best models do not just learn pixels. They develop an internal, intuitive model of the world. This is perhaps the most fascinating part. Researchers believe that by training on such a massive scale, these models internalize the rules of 3D geometry, photorealistic rendering, and basic Newtonian physics. They are not just copying, they are simulating a 3D world and then rendering a 2D video of that simulation. This is why the best AI videos have consistent lighting, proper shadows, and believable object interactions. The AI is not just an artist. It is a director, a cinematographer, and a VFX artist all rolled into one, building a scene in a virtual space according to the rules of your prompt. Let us check the toolbox and the different approaches: Runway, Pika, and Sora. Not all video models are created equal. Different companies are taking different approaches to conquer the time problem. RunwayML is a pioneer in the space. It often uses a cascaded approach, first generating a key image, then using other models to animate it or extend it frame by frame. It is powerful and accessible, but can sometimes struggle with long-term coherence. Pika Labs is known for its strong community and fine-tuned control. It excels at specific styles, like animation, and offers great tools for directing the motion within a scene. OpenAI Sora represents the current cutting edge. Its transformer architecture on spacetime patches allows for incredible minute-long coherence, complex scenes with multiple characters, and a deep understanding of physical dynamics. It shows where the technology is headed. What are the implications? Is it a new reality for film, news, and truth? The implications of this technology are staggering for both creativity and for society. It represents the creative boom. It will democratize filmmaking, allowing solo creators to produce concepts that once required million-dollar budgets. It is a powerful tool for pre-visualization, storyboarding, and experimental art. What about the existential threat? The ability to generate perfectly believable video of anything is the ultimate deepfake machine. It poses an existential threat to the concept of video evidence and could supercharge misinformation and fraud. So, there are ethical questions. How do we label synthetic media? How do we protect the likeness of individuals? How do we ensure the creative work of human artists is not erased? The legal and ethical frameworks for this do not exist yet. AI video generation is more than just a new toy. It is a fundamental shift in our ability to simulate and document reality. We are teaching machines not just to see, but to imagine movement and tell stories visually. It is simultaneously one of the most exciting creative tools ever invented, and one of the most dangerous weapons for information warfare. Our challenge is to guide its development responsibly. What do you think the first thing you will create with this technology? Let us know in the comments. If you found this dive into the future fascinating, please hit that like button and subscribe. Thanks for watching.